everyone, my name is Chandana. I am from Sri Venkateshwara College of Engineering from the Department of Electronics and Communication Engineering. So, today's subject is VLSI. Topic of my subject is the operation of MOS transistor in accumulation, depletion, and inversion mode, and the steps involved in NMOS fabrication. So, firstly, the operation of MOS transistors in accumulation, depletion, and inversion mode. So, as we know that MOS means metal oxide semiconductor. So, these metal oxide semiconductor transistors are fundamental components of modern integrated circuits. These were commonly used in digital logical gates and analog amplifier. They operate in three different modes like accumulation, depletion, and inversion, depending on the voltage applied to a gate terminals and the resulting charge distribution within the transistors. So these are the three modes like accumulation, depletion, and inversion mode. So this is accumulation mode, inversion mode, depletion mode, and last one is inversion mode. So firstly, accumulation mode. In accumulation mode, the voltage applied to a gate terminal is such that it attracts free electrons from the semiconductor substrate. They like usually from silicon towards the surface beneath the gate oxide layer. These create a layer of excess electrons or an electron accumulation layer just below the gate oxide. Next is the presence of these electron accumulation layer forms an conductivity channel between the source and drain terminals of a MOS transistor, allowing to the flow from the source to drain. Next is in these mode the MOS transistor is on and it conducts current easily. It typically operates with positive gate source, that is VGS. Next is depletion mode. In depletion mode, the voltage applied to a gate terminals is negative but not strong enough to invert the channel. Instead, it creates a small region of depleted charges like charge carriers like both electrons and holes beneath the gate oxide. The depletion region reduces the conductivity of the channel, making it less conductive compared to accumulation mode. Next is depletion mode. Most transistors are not commonly used in digital applications but can be found in some analog circuit designs. They operate with a negative gate source voltage that is also called VGS. Next is inversion mode. In inversion mode, the voltage applied to a gate terminals is sufficiently negative to attract charge carriers, electron from N channel and holes from P channel, and create an inversion layer just beneath the gate oxide. The inversion layer forms a conductive channel between the source and drain terminals, enabling a flow of current. In inversion mode, MOS transistors are most common typical used in digital logical circuits. They operate with a negative gate source voltage, that is VGS for an N-channel MOS transistor and positive VGS for a P-channel MOS transistor. Next is the steps involved in NMOS fabrication. The fabrication of NMOS, the channel metal oxide semiconductor. The NMOS means N-channel metal oxide semiconductor transistor. These transistors is complex process that involves multiple steps in semiconductor manufacturing. Here I'll outline the key steps involved in fabrication NMOS transistor. Substrate a substrate preparation, the process being the silicon wafer which serves as the substrate. The wafer is typically made of a single crystal silicon and is highly polished to provide a clean and flat surface. Here we can see the how silicon substrate is going to be a fabric going to under a fabrication. Here we can see the fabrication process. Next is thermal oxide. That is, this is also called as field oxide. A thin layer of silicon dioxide, that is SiO2, known as the field oxide, is grown on the silicon wafer surface. These oxide layer insulates region where the transistor will be built and defines the active areas. Next is photolithography. Photolithography involves applying a layer of photoresist material into a wafer surface. A mask is used to protect a pattern onto the photoresist. This pattern defines the locations of various transistor components including NMOS transistors. Next is exposure and development. The wafer is exposed to ultraviolet rays like light through the mask. The area exposed to light becomes more or less soluble depending on type of photoresist used. After exposing, a developer